Cool. So let us know. Perfect. Thanks very much, guys, everybody. And I think, excuse us for a moment while I hand the controls back to. Right. Stop sharing here.
Yep. And we should be back
Give it
there.
back. Okay.
All right.
And
So, what are we going to cover today? Well, we're going to go over some basic use case data model type stuff. Then we're actually going to go ahead and set up our Astra and get our schema set up and built out. Then we're going to connect with the driver to Astra, and then we're going to run our CRUD operation. So nothing too crazy today. It should be pretty easy to follow along. If you get a little behind, just all the instructions are in the GitHub. You'll be able to catch up just fine, and we can just kind of get through this together as a group. So, yeah, with that, let's take a look. All right, so the app here, if you've seen it before, if anyone was part of our 8-week series, you're probably very familiar with this app. This is the spaceship app. It's basically kind of an IoT-style workload where we have a spaceship that presumably has a ton of different sensors. Obviously, we're spoofing them. We're not actually launching a spaceship here today. But it has a bunch of different sensors that are sending data back, and we're storing those in Cassandra and then retrieving them from Cassandra and doing various things. So we're not actually going to use a GUI on our spaceship app. We're just going to simulate it with a bunch of scripts that we're going to be picking through and working with here. All right. So, designing your data model. We say this, I think, every single workshop, but we basically take relational data modeling and we flip it on its head, where we start with our application now. We actually build out our queries based on what our application needs to consume, and then we build our data model based on our queries. So we're denormalizing. We're kind of taking a top-down approach from application all the way down to the database layer. So what that means is we actually have to sit and figure out what our application needs to run. So what are our queries going to be, and how is data going to be consumed? If we can answer that question, we can build out our data model. So we need to actually, I always use a whiteboard for this when I'm actually working through it with someone, but basically we'll just start with what are the different questions we have and what are the different parts of those questions. So for here we have journey. We're going to have some sort of a spacecraft name or ID, some identifier for a spacecraft. We're going to have a status, so if it's an active journey, or maybe it's a completed journey, or maybe it's planned or something along those lines. We're going to have a summary, so that would be any sort of like mission log notes, something like that. Start time, end time, and then a unique identifier for that particular journey. We're also going to have all these other things off on the right-hand side. We're going to have these sensors that are all going to be feeding data back. And what we're going to do is we're going to put each of those sensor types into its own table. So in this particular case, I think we have one of each kind of sensor. So we're going to have reading speed, reading time, read, unit. All of these things are going to be stored in their own tables, and that's denormalization. The reason we're doing that is it's very, very efficient on data retrieval, where we can just run a direct query without any joins, without anything like that, because Cassandra doesn't have joins. So we're able to run these direct queries and get data back very, very efficiently, very, very quickly. And you can run analytics, you can run all sorts of things against the data you're getting back. All right, so application workflow. So spacecraft, we're going to need to do a couple different things. We're going to need to look up all the journeys from a particular spacecraft. So we're going to be able to basically provide a spacecraft ID and then get all of the journeys associated with that spacecraft. We're going to need to look at the state of a journey. So I've looked up all the journeys for the spacecraft. That one interests me. I want to get more information on that one. So we're going to do some sort of a select based off of the journey ID. Next, we're going to need to create a new journey. So basically, go in and create a journey ID, populate all the info from the spacecraft name, all of the different pieces, and then have that info retrievable. All right, sensor readings and queries. These are all of those sensors again. So this is basically all of your IoT style things in the app. So as these sensors are, updating once every so many seconds, every time interval, they're going to be sending data back. We need a place to store and retrieve that data. Let's see, I think it says here, yep, there it is, less than 100 records per journey per dimension. So dimension there being, our All right, interdimensional space travel, I think. All right, so moving on. Here we go. There's a bit of lag here for me. All right, there we go. So what does this mean? This means we're going to need a lot of different tables. We're going to need a spacecraft journey catalog, that's going to be where we're storing all of our journeys. If we want to look up something based on a journey, we're going to need to look there. We're also going to need one individual table for each of our sensors. So we've got spacecraft temperature over time, speed over time, location over time, and pressure over time. So each of those corresponds to a particular sensor type. Okay, what do those actually look like then? Sorry, the two at the top there, we aren't actually showing you it on this slide. We'll get to those on the next slide. But basically what we have here is spacecraft name is going to be what's called our partition key. In Cassandra, we're not going to get too deep into this, but in Cassandra, things are partitioned based on the data. You can kind of think of it as a giant distributed hash map based on this partition key. And that's how data is automatically distributed for you. You don't actually have to sit there and manually slice up your data and send it to different places, because Cassandra is smart enough to do it based off this partition key. So spacecraft name is going to be the partition key, and then the clustering column, which is an ordering column within a partition, is going to be the journey ID. Now the other cool thing to note here is that when you have a primary key construction, you can actually control some of the behavior of your database. So we have a really good session. I think it was, is it 2 weeks ago that we did our Cassandra basics, Bettina?
It was last week,
actually. Okay,
yeah.
Yes.
And 3 weeks ago.
Yes, yeah, we've done it a couple times. If you want more info on how this works, I highly recommend you look into it. Go check out that session. It's recorded. It's on YouTube. We do a much deeper dive than we're going to do today, and we'll actually cover why these different things are important and how to actually data model on a little bit of a deeper level than we're really going to get into here. So definitely go check those out. Okay, we got our spacecraft speed over time, which you can see there. It's got 2 of those Ks. The Ks, again, it designates the partition key. What that's basically saying is it's called a composite partition key, which is where we're taking 2 values, they're getting added together before they're getting hashed in that hash map partitioning method. So those are both part of our partition key. Both of them have to be provided for us to retrieve data. Partition keys always need to be provided in your where clause for you to get data back. That's the simplest way to look at it, without understanding any of the back end. Just you always need to provide your partition key to get your data back. It's the question, the data, the payload is the answer. Okay, so and then the answer in this case would be speed and speed unit, with, of course, reading time being our clustering column, or how we're ordering it, since we want to order it based on the time that sensor actually read the data. All right.
And actually the tables for temperature and location, they look exactly the same.
Yes.
Right?
Yeah.
So they basically have, and that's why we don't display them. So we just basically have 4 dimensions. We've got speed, temperature, location, pressure, and we're recording, at in a very rapid intervals.
Right.
The journey, telemetry details, basically. Right?
Exactly.
So those look exactly the same.
Yeah, and so I'm not going to go through the pressure here because, again, it's just like Bettina said, it's the same exact thing. All right, so now we need to look at some types. Data types, they're important, right? All right, I'll start here on the spacecraft journey catalog. The name, obviously, that's got to be text. Text is basically your equivalent of like a varchar, or kind of the char equivalent in a lot of other databases. It is basically string. Yeah, that's the other. It's the one type that handles all of those things. You don't need to specify a length on it. You don't need to do anything like that. You just use type text and you're good to go. Journey ID is a time UUID, which is a very, very cool type, because it's basically a UUID, which is a unique identifier number, but then with an embedded timestamp that can be ordered. So you can actually go through and you can actually order things based off of these unique identifier numbers, given the fact that they store this timestamp in them. Really, really nifty. Super, super cool tool, and actually simplifies a lot of the things around data modeling later on. But again, not getting into that. If you want to see more on that, check out last week's session. All right, so we got start time, end time, which are both going to be timestamps. We've got active, which is a Boolean, so basically true, false. And then summary, which is, of course, another text. So that's probably short little paragraph of went here, did that, came home, that sort of thing. Same sort of thing for the sensor tables. Again, I'm only going to cover one of them because they're all essentially the same table, just with different a different thing. The pressure versus speed versus location contained within them. So there we have spacecraft name, which of course again is text. We have a journey ID, which again is that time UUID. Notice both of those values are actually stored in the spacecraft journey catalog. So that's kind of an interesting point, and we're not going to get too deep into that either, but for now, understand that we're not doing any joining. We're actually going to probably what this would look like from like an application standpoint, where I'm programming a UI or some sort of a dashboard on top of this, is I would click on a journey from the journey catalog, and then it would actually run another select statement using the journey ID and the spacecraft name. So you can actually retrieve stuff that way. It's pretty cool. Okay, reading time, timestamp, and then of course speed, and then speed unit, which are double and int respectively. Okay, whew, that was a lot. All right.
You get to do it yourself in a moment.
Yes, we'll get to try it. All right, so create table if not exists. This is your standard create table statement. This is basically exactly what you think it is. Similar to almost any other database you'd use out there. You have a key space, which we'll create in a moment, and that's a bucket that stores tables. Then you have your tables, then you have your data in the tables, stored rows and columns, and then of course, like I said, that thing earlier about partitioning, all those rows are chunked into these blocks called partitions, and those are distributed. So, but from your standpoint, it's just nice rows and columns. You can run selects like you think you would. You can get your data back in result sets like you think you would. It should feel very comfortable to anyone who has run a relational database in the past. You're going to feel right at home here, as long as you're understanding the denormalized nature of things. So, all right. So we're going to do create table if not exists, spacecraft journey catalog, and then we're going to go through. We're going to define our attributes and their types. Then we're going to build that primary key. Now this is where the magic is. So remember how we said the primary key determines partition and ordering. You see there the partition key is that spacecraft name, and it is in an extra set of parentheses. That basically just says, hey, this is the partition key, use this value, and do your hashing based off that. Then your journey ID is outside, it's got the comma, journey ID, and it's outside that what do you call it, inner parentheses set, I suppose. That is basically saying that this is a clustering column. This is what we want to use to order our data. And I believe, Bettina, by default it's descending, right? Is that correct?
I think by default it's ascending,
okay,
as far as I know.
Okay.
And, but I might be wrong.
Yeah, it's one of those ones I always have to look.
Something that I always look up.
Yeah.
So, yeah.
Okay. So, and then, of course, with clustering order by, and then journey descending, if you wanted to manually set an order on that. So
that would basically give us, if you looked at the partition, that would give us the most recent journey first, and then the later ones. So that's really, so you would retrieve everything for one spacecraft, and you would see the different journeys that the spacecraft has taken.
Yeah. Okay, so now we have the other table, which is the sensor table, and I'm only going to show, I think, one example of this, just again because they're so similar to one another. We have our spacecraft name, journey ID, all of it's set up the exact same way, but you remember that composite partition key I mentioned earlier. That's how you denote one right there. You'll notice those inner parentheses actually have two values, so they have spacecraft name, comma, journey ID. That is due to that is how you denote, goodness, words aren't working for me today. That is how you denote that it is a composite partition key. And we still have a clustering column there. You see reading time is, again, outside of those inner parentheses. So that's kind of how you set up your table structure. It's really not that difficult. Once you do it once or twice, it should feel very comfortable. There's just nothing crazy there to understand, really. Okay. So,
yeah, we've got one, because we get this question all the time. How do we deal with UDTs, user-defined types? So we've got an example here, and then we see it later in the code. How do you deal with that? I thought it was interesting to include that.
Yeah. So UDT is, just like Bettina said, user-defined type. Essentially, if there is something you wanted to store and you wanted to do it in a single cell, but you had maybe multiple data. So say maybe you have a user database and you have an address or something associated with a person, you could potentially store that as a UDT. And essentially what we're doing here is we're defining, so create type if not exists, location UDT. And that's just an XYZ coordinate, so a three-dimensional space coordinate. And so when I insert data, I'm going to provide an XYZ coordinate. It's going to store that in a single cell. It's going to be retrievable by a single cell, and give me my data back. It's kind of the simplest way to explain it. There's a little more complexity when you get into some really advanced stuff with them, but for now, just think of it as storing multiple values within a single cell, multiple related values within a single cell. Don't try to go and make a database in a database, though, and like try to nest all sorts of stuff and that's a pitfall I've seen people fall into before, where they go, "Oh, great! I can return everything from one cell," and then it just turns into a mess.
Yeah, they're not silver bullets, right? So it's just but I think the drivers actually handle these things a little bit differently. So it's worth exploring it in the examples that we have, but it's not something that don't fall in love with user-defined types, right? So it's they make things extra complex. But it's worth pointing out how it works.
Absolutely. Okay. I'm going to go ahead here and go to the next. Oop, there it goes. Okay. So when I actually want to use this UDT, what I'm going to do is you'll notice there under the location, I've got that frozen and then location UDT type. Since I've already created that UDT type in my database, it understands that that is what I'm using. And it will actually go and take those three values, and it handles all that for me. I don't have to do anything else. I just insert my data, retrieve my data, good to go. Simple as that.
And the frozen just means it has it as one block, right? So it always expects X, Y, and Z, right? So it's just don't trip over that keyword, but it's just one blob of data basically there.
Yes, absolutely. Okay. So, got through all that. We get some hands-on.
Let's get going.
Yes. So, what is Astra? Astra is what we're using today. It basically allows us to get rid of a lot of the time we would have spent setting up our database. Previously in years gone by, we would spend half the day standing up Cassandra so that we could run a couple CRUD operations. We don't have to do that anymore. This is a fully managed self-service database. So Cassandra is the back end of Astra. Everything on Astra is basically running on Cassandra. There's no commitment. We're not taking credit cards or anything today. We're not using this for marketing literature or anything like that. Marketing emails or anything like that. There's a free tier. We're going to use the free tier. It's 5 gigabytes. Always there till Astra goes away, basically. It's just a way to eliminate the operations for today so we can get straight into the code. So, all right. So if you made an Astra database in a previous workshop, feel free to keep that. Our code is very friendly. We'll just have to change like 2 values, and I'll point them out when we get there. You'll just change 2 values to match whatever it was you created previously. If you haven't created one, that's okay. I'm going to walk through it with you, and you can follow along step by step, and we'll get through it. Okay. I am going to, let's see, hands-on exercise, create Astra database. Cool. I'm going to go back over here. So the GitHub was linked earlier. Hopefully everyone here had it. You'll notice.
I think you might want to make that a little bit bigger, Eric.
I
think it's a bit small.
Let me increase. Is that better?
To me, that looks good. So let's see what our friends say on YouTube. Let us know if it's good enough.
Yeah, if it needs to be expanded, I always make it a little bigger. Okay. So we're going to scroll down here. Now, first thing I want to point out, you got a table of contents. If you're doing Node.js or if you're doing Python, we'll click on those links later. So not right now. Just know that that's where they are, and that's easy to get there if you click on there. All right. So first thing we're going to do is we're going to go to Astra. Now you can click here, and it will lead you there. I was a little sneaky earlier, and I already am there. Although I think I do need to re-authenticate because I've had it sitting open. Oh no, cool. All right. So when you get to this page, it should look like this. You'll have your account. You can see I'm logged in. I don't have any databases, which is totally fine because we're going to go ahead and hit that Add Database button right there. I'm going to select the free tier. I'm going to go down. I'm going to make sure Google Cloud is selected. Now this next part, select the one that's closest to you geographically. For me, I'm in the US, so I'm going to do US East, but if you were in Europe or Asia, obviously Europe West is probably a little bit better option for you. All right, and then I don't have to do any sort of estimated cost because, again, it's not asking me for any money. It's not asking me for any credit card or anything like that. I'm just going to go ahead and I'm going to click Configure.
And that configure button is right behind Erick.
Oh, yeah, I'm sorry. Yeah, here, let me move myself aside, actually. One moment. Whoa, didn't want to move that. I want to move... it's going to be hard to move myself without messing up a bunch of stuff, so I'll just keep going. All right, so database name. Now you'll notice over here in the README, we actually tell you all the values to use. Again, if you use different values from a previous workshop, don't worry about it. We'll point out where you got to change the code.
It's absolutely fine.
But if you're making a new one, I highly suggest copy pasting. And oh, I just noticed we have a typo there. That period is in the code block. Don't copy the period. The period's not part of it. But
actually, can you refresh? Can you refresh your GitHub because I changed the values there?
Okay. Yep.
Yeah,
okay. You totally did. My apologies. I am out of date.
There you go.
Right, the space name is spacecraft, and then suser.
These really don't matter too much. There's only 2 places today in our code where you would have to change them, right? So if you use something different, it doesn't matter, right? So
okay, I'm going to go ahead and click Create Database, and that should start spinning up. Now we'll notice here this is kind of grayed out a little bit. Our database is being spun up. I can actually go click on it, and I will see here.
It's pending. You see it pending, right? It's not quite there
yet.
Fine.
That's totally fine. We're just going to leave it there. It's going to do its thing, and I'm going to go back to the README, and I believe that puts us all the way down at step, 1D, which is view our database and connect. Now, again, ours is pending. It shouldn't take more than a minute or two. Still pending. Shouldn't take more than a minute or two.
You're active? Are you active already? Oh no, still pending. So if you're getting to active in our audience, just give us some thumbs up so that we know they're fine. And would like to know how many people are actually coding along. It would be great if we get, everybody.
Yes. All right. So what we're going to do then, there we go. Perfect. Mine is now active. You see that status right there? It says I'm active, which is perfect. That's exactly what we want. Now, again, following the README, we're going to go down, and we're going to connect to the CQLSH console. So how I do that is just this right up at the top. I'm going to click on that, and it's going to bring up an in-browser terminal window, essentially. Give it a moment here.
Oh, look, we don't have to put the password in anymore.
Yeah, that's a brand new feature. I think that was this morning.
That's a change as of today.
Yes. So it is so nice compared to having to actually type your stuff again. So you can ignore the type your username password. That's a holdover from yesterday. So, all right. So now in our database, we are going to type this, use spacecraft. This command is just like you'd expect from any other database. This basically sets a context. And you'll notice our prompt there says now we're in the spacecraft. If we didn't want to set that context, we could actually fully qualify all of our commands by using, where you say select, like, for example, select from, we could say spacecraft dot and then the table name, and that would fully qualify everything, so we could actually return data back. But we're kind of going easy route today. And we're just going to say use spacecraft and then forget about it.
It also makes it easier in case you have your own key space name and someone else, so we can just sort of like, you can just copy and paste everything in there. So it doesn't need space.
Absolutely. Okay, and that's, whoa, uh-oh, that's not good. Let me refresh here. CPO console. All right, and I'm going to go ahead.
What's
right, because I didn't use. All right, use spacecraft. And I'm going to go ahead and I'm going to just paste that schema that we have in the README, and that's going to go ahead and create a whole bunch of tables for me. Basically, all the tables we discussed when we were going through the slides. So if you want to look through them, feel free. They are exactly the same way we set them up before. All right, there we go. My schema is created. And then if I want to take a look at it, I can actually use this describe command. So this will show me what actually is in my database, and I'll show you a couple things there. We got, yep, all of our tables are there. Perfect. All right. Now,
Right. You want to give a minute or two for people to catch up?
And I'm actually going to show another thing while people are catching up. I'm going to do another describe command. This one is really useful if you are trying to figure out what your table looks like. So instead of tables, I'm going to type in table, and I'm going to, let's do spacecraft journey catalog. And, oh, did my keyboard, there it goes. All right, and I can actually see my table structure. You can see I've got all of my values, all their types. I've got my primary key there. I can look through this and I can see everything that I would need to actually make a modification or work with this table. There is all this other stuff at the end here. This is all operational stuff. Don't worry about that right now. If you were going in and doing like some really, really deep level, elite Cassandra tuning, you'd start messing with these things. But for now, don't touch them. Don't worry about them. They're just there so you can actually tune tables in Cassandra. But again, we shouldn't need to do that today. And 99% of people who use Cassandra are never going to touch them. Just generally not needed. Okay. All right, so setting up our IDE is going to be the next part, and I'm actually going to close my cooking show stuff. Go ahead in the.
You want to wait a little bit until everybody has created a database, etc.
Thumbs up in chat when you've got your databases. That would be excellent. Bettina, I'm going to rely on you.
And to put the tables in, etc.
Yeah. Get some.
So there were a couple of questions in the meantime.
Absolutely.
So what the difference is between a time UUID and a timestamp?
Yeah, that's an excellent question. So a time UUID, it takes the type of a UUID, which is this really long, unique number. It's basically a gigantic integer, and it takes that and it combines it with the concept of a timestamp, which is, a time that you can reference. And it combines the two into this gigantic, unique number with a timestamp. I think it's the predicate of the UUID. Is that correct, Bettina? The predicate is the timestamp.
Yeah, I think it's one of those fields in the middle that sort of like specifies it as a time UUID as well, and then there you have that code that resolves to the time.
Yeah. So basically, it's combining two types into a single type that gives you both a way to order and sort data, but also provides a really, really strong uniqueness to your data, which in a denormalized
and it's used very heavily with Cassandra, so all the UUIDs and time UUIDs, and we have driver functions that make it easy for you to generate those, right? So you can generate them with the driver, but you can also generate them. The database itself can generate that for you, right? So with the Cassandra query language.
Yeah.
So it's a good concept because you want uniquely identifiable records, but it's also a concept that's very well supported by all the tools around it. So it's worth sort of highlighting that later when we come to that part in the code.
Absolutely, yeah, and we can definitely do that for sure. Are we getting many thumbs up?
Let's have a look. Then let's see. I don't know. I don't see that many thumbs up, but just let us know when you're done, or also let us know when you're blocked, right?
Yeah,
so that we
can
see what's.
Okay, I'll give it another minute or so, and then I will.
Yeah, let's give it another minute, and then we set up Git pod,
yes.
And then from then on, it's going to be really coding. So another question was, in the meantime, what the Ks and the Cs meant in these kind of data modeling diagrams. So the Ks are for the primary keys, and the Cs were for the clustering columns. So together they make up, no, the Ks are for the partition keys, sorry, and the Cs are for the clustering columns. Together they make up this unique key of a row. So that's, I hope that explains that.
Yeah, you can kind of think of it almost like an address on an envelope, where you've got data isn't indexed natively in Cassandra. It's actually kind of a direct lookup approach. So what that primary key actually is the address of your data. It actually determines what node in this giant distributed Cassandra cluster your data lives on, and then where within that partition that lives on that node that data is. So it's basically like an address on an envelope that allows you to not even need to use an index to get your data back. Okay, we're going to go ahead and...
Okay, we've got a lot of people saying, or we've got a few people saying DB is up.
Perfect.
So we could probably go proceed.
All right, so I'm going to go ahead and I'm going to open Gitpod. I'm on a Mac, so I'm command clicking that, so it opens it in a new tab. And we're going to go ahead and let that load up here. Gitpod, for anyone who hasn't used it, is essentially just an online IDE. It's very similar to like VS Code. I think they're actually using the same material UI elements between VS Code and Gitpod, which is technically using Theia, which is an open source project. So, okay. So we got our README there, just like you can see before, the same stuff we were just going through on GitHub, which is really, really nice. I'm going to go ahead and go into the Python and just look at, I've got all my files here. I've got my Python-specific README, which we're going to...
You definitely want to zoom in, right,
a
little bit so
again?
people see what you're doing there. You want to zoom in a bit there.
Is that a little bit better? Hopefully that's good.
I think it's good for me, right?
Okay.
And just we figured out today how to make it with the light theme. I think if you launch Gitpod by default, you will have the dark theme, but it's easier for presenting.
Yeah.
So just in case you wonder why it might look different for you.
Yeah, absolutely.
And
okay, so what we're going to do now, I'm going to show you just a couple files. We're not going to mess with anything yet, but we've got our DB connection file. This is literally where we go and put all those values that we defined when we created our database. We're just going to throw them in here, and that's going to allow us to actually connect along with the Secure Connect bundle thing, which we're going to mess with in about 2 seconds, or probably a little more than 2 seconds. But then we have all of our operations here, so doing things like actually trying to connect to the database. We're going to do some inserts. We're going to do some more inserts, or an update, I suppose. And we're basically going to go through all these different CRUD operations. And I'll dig through the files a little bit as we go, depending on how tight we are on time. I want to, kind of show off some of what's there. So, okay, that is basically all we're going to do there. I'm going to go back to the slides, and we'll keep on going. All right, so now that we have our database, we actually have to connect something to it, right? And I mentioned earlier we're going to use a driver to connect. The driver literally is just a thing in our application that speaks the language of Cassandra and that Cassandra can speak back to. So it allows us to run our CQL statements, select from, all that stuff. It allows us to submit that out to our Astra, which is, again, just Cassandra in the cloud, self-service. You'd be able to set up your driver if you had a local Cassandra cluster to do all the same statements. Everything else would be the same. It would just be a slightly different connection info in your driver. So really, really simple, really, really easy to do. All this stuff should translate really well if you use Cassandra professionally or if you're just getting into it now. Okay, so drivers. There are a ton of different drivers. We're going to focus on 2 of them today. We're going to focus on the Node and the Python. There's also a Java driver out there, and then there's a whole bunch more. A couple of these are end of life. I don't know which all of them are. I know the Ruby one, I believe, was. I think C and C++ were end of life.
yeah,
I don't know about C#.
you don't even see the PHP driver, and this PHP driver is actually stopped. But there are, these are just the DataStax drivers, and there are also quite a few community drivers that are available. But we aim to cover the most popular ones. So.
Yeah, absolutely. And there's a lot of words on this page. All I want you guys to understand is that they basically take care of all the difficult Cassandra things for you and allow you to just write your statements and get your data back. That's as much as you need to understand here today. All right.
Exactly.
So to install them, we're going to use our language-specific package manager. So in Node, that's of course npm, or Node Package Manager. And in Python, that's of course pip, which actually I don't know what pip stands for now that I think about it. I've used it hundreds and hundreds of times, but I've never sat down and actually looked that up. So yeah, All right.
Python installation something.
Package,
I would guess.
Package something. Yeah, I'm sure we're probably going to get corrected in the chat there, but you know. Yeah, so basically we're just going to go ahead and we're going to install Cassandra driver. And don't worry, you don't need to do these as I'm doing the slides. I'll walk through these with you as we're going here. Okay, then we're going to set up our actual connection. So in this particular case, what we're going to do with the node is we're going to create that client. We're going to specify basically our different credentials. We're using what's called a Secure Connect bundle, which is just a zip file that has a bunch of kind of certificate stuff and configuration stuff in it. We're going to download that in just a couple of minutes here and set that up. But essentially, we just set up this client object, and then we're going to use that to submit all of our requests. We're doing essentially the same thing in Python there, although you can see there's a little more code that goes into it. Still not bad, though. It's all the same stuff. These are essentially perfectly equivalent to one another, just some slight syntactic changes. Okay. Important about the session. If you open a session, you need to close the session when you're done with it. The reason for this is that sessions are very expensive objects. They actually have a connection pool associated with them. They consume a lot of RAM. If you start opening lots of sessions, you can actually very quickly eat up all your RAM. I've seen that happen many times. Make sure you're closing sessions you're not using. And this is true of any database. This is best practice. If you are using a database and you're opening sessions, you need to be closing your sessions when you're done with them. In order to do that, in Node, it's client.shutdown. In Python, it's session.shutdown. Pretty simple. All right. Now we're going to do the next hands-on portion, which is go ahead and click on the language of choice in that table of contents. So if you want to do the Node, click on the Node. If you want to do the Python, click on the Python. I'm going to be doing Python here today. That's the language I prefer, but do whatever is best for you. And again, just syntactic differences between the two. All the concepts we're discussing are going to be exactly the same.
But they're very similar.
Yeah.
So in case, so you see less difference than with Java, for example. So it makes sense to cover them together.
Absolutely. All right, so we're going to go through and we're going to actually get the Secure Connect bundle. So how we're going to do that, I'm going to go back to my Summary tab. I'm going to click on Connect, and I'm going to click on Driver. Now you'll notice that there's also a REST API and a GraphQL API. You can actually submit requests through those APIs if you so desired, but we're not going to do that today. Just understand they're there. If that's something you're more comfortable with, if that's something you'd rather use, there's documentation there. There's the REST API endpoint for you. It's all pretty easy. It's all there, and you can look into it. We're going to go over here to the driver though, and we are going to right-click on Download Secure Connect Bundle, and I'm going to save link. Copy the link.
Yes, copy the link.
I do that every time when I'm doing it myself.
I know, I did this a few times.
Habit.
Just copy the link address. That's all we need.
And then we are going to actually, I'm going to scroll down here because it's actually going to show me the command I need. I should have done this in a different order. I'm going to copy the command first. And I'm going to copy up to there, and then I'll copy it in two parts.
Copy up to there, yeah, exactly. Oh no, but now you don't have to have it in your clipboard anymore, so you have to go back to Astra.
Yes, I do. So copy link, address, and again, if you guys get stuck on this, please say in chat. We are here to help you. All right.
You're using a command, and you need to wrap your link into double quotes.
Exactly.
Right. It will actually not throw up an error really if you don't do that, but you don't get the right thing. You need to wrap it into the double quotes, and then you want to redirect it so that it gets saved to creds.zip in this case, whatever, it's your
Yes.
choice, right? If this was success, you should see that about 12 kilobytes have been downloaded. You know, the received size here, right? It should be about 12 kilobytes. And if you have less than that, you might want to refresh your Astra screen before you copy the link, because the link is only available for a short time, right?
Yes.
It's only 5 minutes.
The other thing I'm going to point out here is, since I'm using Python, I'm going to change directories into the CRUD Python directory. So in Linux, since this is a Linux terminal, that's just cd and then CRUD-Python. If you're using Node, it's just CRUD-Node.js, and that will get you into the right directory. And then if you wanted to check and make sure everything was there, you can obviously see it on the side panel, but I'm a command line nut, so I'm going to just ls, which is going to list out my files, and I can see that my creds.zip is in fact there, and it should be referenceable for my code now. So, awesome, we did it. Now we're going to go back to the README, and there's two more things we've got to do. One of them is install your driver. So again, on Node, this would be an npm install. On Python, we're going to do our pip install. I'm going to go ahead and run that. Pip install Cassandra driver. And that goes out basically to the pip, I think it's pypi package manager, I think, in Python. Yeah, I need to get a little more educated on that part and how the inner workings of the backend package manager work. Basically, it goes out, it grabs the driver, and it goes ahead and installs that, so it's then referenceable in our code. All right, and then the last thing is we have to match in that DB connection file. We have to match all of these values to what we used. So, if you had a database previously and you just wanted to use it, you're going to have to go in here, and you're going to have to change these values right here to match whatever you had. So if you were in a previous workshop, my guess is you probably have something called killer video for the key space, and something like kv user, kv password for the username and password. If you were doing it here today, and this is brand new, I believe, let's see, suser, password, spacecraft, yeah, those should all be current from today. So I'll give you guys a moment to get that sorted out, because that's kind of an important little piece. None of this really works unless you do that.
That's actually the only change you need to make today to the code, but that is really important. And actually what is really important is that you get the directory, the path of your Secure Connect bundle right here, because otherwise you see a lot of strange errors because you cannot establish the connection.
Yeah. Okay, now the other thing I will show you guys here is a Secure Connect bundle. This path is going to match wherever you stored that. So if, for example, I were to change that curl command and put the Secure Connect bundle in a different place, I would have to change this path right here and, you know, basically point to that new location. Just pointing that out, everything today should run with defaults, no worries, as long as you're running your curl command and the code here exactly as they were in the README, it'll work. But just understand in your own apps, you don't necessarily have to store the creds.zip in the exact same location. You can move it where you need to move it. Okay. Next, we're going to do our...
So, do you want to let us know whether that works? I mean, have you got the secure bundle? Is it curled properly into your Git pod? Just give us a little bit of feedback in the chat, so we know that you're catching up.
I'm actually going to do... I'm going to go ahead. I'm going to run the test connection, and if you can give us... Everyone can give us a thumbs up when they run it and it succeeds. So Python, we're going to call that file right there the example 02 connect to Cassandra. This is just going to go ahead and test our connection. It starts, it says success, and then it closes. If that worked, you're configured correctly. So go ahead and give us a thumbs up as soon as you get there.
Yeah, we've got quite a few people who say they're done. That's so
wonderful.
Cool.
That's wonderful. All right.
You're connected. There you go. All set up properly. So that's your exercise 02. EX02 is your test. It's set up. And that's exactly the same for Node, right?
Yep.
So if you're doing this exercise with Node, all the exercises they really like, right, to have the same name. But you launch them, obviously, if you install with npm, and you launch with Node, right? So, but other than that, they're very similar.
Yeah, absolutely.
Coolio.
All right, so
good.
moving on then, I believe I am going to leave that here, and I'm going to run this through a couple more slides, and then we'll get some more hands-on. Oh, wow, that was a lot, wasn't it? So what we did...
Well, we've got that out of the way with the secure bundle, it looks like. It's just...
we went and we downloaded it, we got it working, should be good to go there. All right. Here's the stuff we've been talking about all day. We actually are going to run some CRUD operations. The cool stuff. Get data in, get data out.
Exciting.
Yes. All right.
Exciting.
So what we have here are simple statements. Now, simple statements are basically a way to just write some CQL, slam it into the driver handles it, returns some data, boom, good to go. Things get much more complex the deeper you want to go with this, but a simple statement is the simplest way to execute a command against a Cassandra cluster. Simply put, simple statement. What those look like are in both the Node and the Python. We take that session, so Node we say client, in Python we're saying session, dot execute, and then we're literally typing out a statement. And then you'll notice that in the Node we have a question mark, and then the value behind that gets inserted where that question mark is. In the Python we have that %s, and then the value gets inserted there. So a little syntactic difference.
Yeah, that's worth pointing out that you're doing a string replacement, right? It's always a string. Don't use %i,
right.
Even though you're inserting an integer after that, right? It's always a string.
And it's also worth pointing out that this method of doing things is not really injection safe. But, for today, we're doing some simple statements, and I think we actually cover prepared statements and things in a couple slides. So
absolutely,
we'll get into that.
Indeed.
Yeah. Oh, yeah. Not even a couple slides.
There you go.
All right. So prepared statements are the right way to do things for a few reasons. Number one, they are what allow you to take a statement and only need to send it once, basically minimizing your traffic. So that what happens is that statement gets prepared, right, prepared statement, on the actual nodes themselves within the cluster, and it gets an ID. And both the driver and the nodes understand what that ID is, and they can communicate by saying, hey, run statement with this ID with these values, instead of having to send that whole, select star from blah, 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 with blah, 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 blah. That huge thing that takes up a bunch of network traffic. They say ID, values, boom, do it, send me the result. So it's kind of an optimization. It's very efficient, and it's also much safer when it comes to injection than a simple statement. Okay, so a couple things here. You notice we have defined our query. So we have const query, select star from, and we still have that question mark there in our node, and we now in the Python notice there's a question mark. So don't use that %s. Use a question mark to specify this is the value that's going to be replaced when we actually run that statement. Okay, an important little difference. It doesn't seem like much, but it will trip you up if you just switch from simple statements to prepared statements and expect it to work.
So true. For Python, it trips you up.
Yes. Right. Other than that, this should all be pretty straightforward. Obviously, you're seeing we're running session execute. We're running prepared, which is the statement. In the Python there, it's prepared. In the node, it's the query. And then we're sending that value. Also in the node, we're setting the prepare equals true. Again, everything that's actually functionally happening here is basically the same between both languages. It's just a little bit of syntactic difference, and just do it in a language that you're comfortable with, and it's totally fine. So we'll go ahead, and we're actually going to run some of those now. Now, before I actually run the code, or maybe after I run the code, we'll see. We're actually going to pick through it a little bit. I think we have time. How are we doing on time? We've got...
Yeah, we have time
perfect.
for that.
Let's get our hands dirty then. Let's get into this. All right. So, you'll notice all of the exercises are ordered. It makes it really, really simple to follow along. I am going to go ahead and I am going to go back into my Git pod here. And I'm going to go ahead and click on Insert Journey. And let's scale this down so it's a little easier to read. All right, so what are we doing here? We're importing our connection, right, from the DB connection. So that's setting everything up. So we don't need all that code here. We just did that once, now we're good to go. We're importing UUID, which is a type that we're using, right? So we've got to insert a type. We're setting up a journey ID so that we can actually insert the journey ID. And then our spacecraft name is defined here. So this file is essentially just inserting a single journey, right? This isn't a generator or anything. This is just, let's build out a journey and simulate running a journey right now. What do we need to do to do that? Okay.
And can I just interrupt for a moment? What we are doing here is that we're actually hard coding our UUID. Yep. So because we will come back to it with every next exercise, because we're focusing on this particular journey. Right. But as you see, what we commented out there is that you could also generate your own UID, right? Your own specific, which would then have a proper timestamp and everything, right? So this is for the purpose of the exercise. You would then have to go and change it in every next exercise. That's why we hard-coded the UUID in here. But you can, normally you would probably generate your own.
And yeah, it's a bit of cooking show magic, but it does make the thing run smooth today.
Exactly. Something a UUID prepared earlier. Right. There you are.
All right. Okay. So here what we're doing is we're defining our connection as the connection we set up earlier. We're saying, okay, output connection session.execute. Remember, that's how we're executing a simple statement. We've got an insert statement here. Literally insert into, we got our table name, we've got the different values we're looking for, and notice, since we're using a simple statement, in Python only, if you're in Node, it's going to be different, but in Python, we're using the %s, and then we have all of the values that we're actually inserting right after that in the brackets. Goodness, I was thinking braces there, and I couldn't remember the word brackets. All right, so that's a simple statement. Simplest you can get, really easy. I'm going to go ahead and I'm going to run that, and then I'm actually going to show you that I can't type and talk. It's a really bad skill for a presenter not to have, not being able to type and talk. All right, I'm going to go ahead and run that, and then what we're actually going to do, all right, so success, I'm going to go back to my database, CQL console, connection closed. Let's go ahead and hit connect, come on, CQL console, boom. All right, oops, I am not typing correctly. So I'm going to go ahead, I'm going to use spacecraft again because it signed us out, we took too long, one of those security features. They're good. I'm going to type in select star from catalog. Now, generally, I wouldn't type this. I know there's only one record in there, but if it was a big table, there were tons and tons of records, I could basically cause a full table scan, and that's really, really bad. Again, I kind of a cooking show magic for today. I know there's only one record in there because I only inserted one record in there, and I just made the database. So I'm going to do something a little not safe. And hey, look, that is exactly the same data that we just inserted. And you'll notice here, if I go back to, yep, there we go. If I go back to the statement itself, we have all the data there. Now, it's important to note there, the nulls, the start and the end, aren't actually there yet because we have not started the journey. We'll get to that in a moment, where we actually get to start this journey and end this journey, and then we'll actually do update commands to populate those fields. But for now, just notice.
And you can see we don't have to submit them. We didn't send the values, right? We only set spacecraft name, journey ID, and 2 data columns, active and summary. So if you don't set it, it won't get stored.
And don't ever explicitly insert a null. That's actually a anti-pattern in Cassandra. It causes some issues. Basically, deletes are null inserts, are handled as null inserts. So if you're inserting nulls, you're actually saying, hey, delete this data. Hey, delete this data. Don't do it. Just omit the data if you don't want the data in there, and that's totally, totally acceptable in the Cassandra world. Okay, see, I think we had to go through, through 4 as well. All right, so let's take a look at what we have in example 4. We have simple, there it is, prepared update. Oh, we're not on simple statement, we're doing a prepared statement. Okay, so this is really, really cool. If I go up here and I look at this query, this update query, notice I've got that whole statement typed out. Again, instead of that %s, we're now using the question marks. So really, really, it's something that will trip you up. You'll do it once, and then hopefully you'll never do it again. We're using our question marks there, and we are basically taking that same UUID that we had from before, the same spacecraft name we had from before. That's where the cooking show magic that we talked about came in. That allows us to reference it directly as opposed to generating something random, having to look it up, and do everything that way. So, right, so here's our query. It's called update query. And then notice this, prepared update, connect session, prepare update query. What I just did there is I said, everyone, the driver, and all of the nodes in the cluster need to understand that this statement is going to be a prepared statement. So they're all going to basically cache that statement and have a consistent ID between all of them so that we can do that. Just send an ID and some values to run with that statement and return our data. So that's the actual prepare step that makes it a prepared statement. Next, I'm going to go in and I'm going to take connection. Oops, that stuff popped up. Connection session execute. I send my prepared statement, which again in this case is just going to be from the driver's perspective an ID, and I send my values. And remember, we defined that those individual places in the statement were where we were going to replace values. So we have update, a certain value, and then we have our where, and then we have the other values. So that's basically what a prepared statement looks like and how to use it. Pretty simple. Let's actually run it, and Python 0.
It's for number 4, right?
Yes. So we're actually going to run that there, and we've got our nice little printout of ignition, success. I'm going to go back to my database, and remember, we had these were both null. Now one of them is now set to true, and we actually have a start timestamp there. Pretty cool, huh? So we just performed an update statement. So we've done insert, we've done update. Now we get to do the remaining, and we did selects too, because I'm running selects here. But we're going to do it programmatically. We're going to do a select, and we're going to do, I believe we do a delete as well.
Yeah, first we're going to update our UDTs and just to do a little bit more interesting. So the exercise 5 is actually the most interesting out of all these update exercises. It's the longest and it does the most. So probably want to explain that a little.
Yeah, we'll get into that in just a moment because we get to talk about batches. Batches are a wonderful thing.
Everybody loves batches. How's it going, guys? Give us sort of like, are you catching up? Is it different? I can't imagine you find it too difficult. So just let us know how it's going. If you have run into any issues.
Absolutely. Okay, I'm going to take a brief moment to discuss batches. What are they? Why are they useful? And what are they not? First, I'll start with what they're not. They're not a relational batch. They're not an optimization step where you just package up all your queries in a batch and run it as a kind of a job, and then you're done and it's super efficient. That is not what they are. They are simply a way in a denormalized system to keep tables with similar data consistent with one another. Simplest way I'm going to say it, I'm not going to go super deep into it. Again, we've done plenty of content on it in weeks past. If you are curious, go check that out. But understand, they are simply there to keep like data across multiple tables consistent. So I'm not going to use them as an optimization. It will actually cause performance degradation if I do so. Okay, so what is a batch? It's basically a set of statements, all in a group, that's run as essentially a single job. In Cassandra terms, it goes to a single coordinator node and is handled as kind of a single operation made up of multiple operations. In the simplest terms. Do you have a better way to explain that in kind of 10 seconds, Bettina?
No, that's good. Okay. That's good.
So what I've done here is I've taken var my batch. Actually, I'm going to go with Python because I'm more comfortable with Python. So I've got my batch statement, batch equals batch statement, batch dot add. You notice I have my prepared statement. I have a prepared insert location, prepared insert speed, prepared insert temperature. All of those are prepared statements that I have in advance, and I'm calling them from a batch. And then I have all my values there. So I have my spacecraft name, journey ID, location XYZ, which again is that UDT. We'll get in that moment. Read time. All of those things are just sent as part of that prepared statement. All those prepared statements are just part of the batch. I send that off with the connection, session, execute, and then just throw the name of my batch in there, sends it off, does the operation. Pretty simple, nothing too complicated.
So I think what's worth pointing out here is that this is actually one of the areas where the drivers differ a little bit in terms of behavior. So the Python driver gives you this object of a batch statement. It has this object of simple statement, object prepared statement, and object of batch statement. And then you just add those statements to it, right, for Python. And then you execute it. Versus the node driver basically has a method, called batch, which is basically then executing the batches that we defined basically in this. So it's worked a little bit different, and I thought it was worth pointing that out because it's one of the questions that we see a lot in the community. How do I really do batches and in the different languages? So this is an area where the drivers can differ.
Yeah, absolutely. That's an excellent point. Okay. UDTs, Python special. Bettina, would you like to talk to this a little bit? I think you're a little more familiar
it's another
than I am.
area where it's another area where the drivers can differ, right? And it's also actually the same for the batches. It's not necessarily the only way you can do it. So for the purpose of this workshop, we've taken the easiest route here is that we just create a class for the user-defined type, and then we refer to the class. And that means we don't have to do anything special. In general, it's actually, if you read into the driver documentation, and I've put a link to that into the GitHub repo, I think, it is recommended that you register the UDTs with the cluster instance, and there's a couple more steps to go to, just to make sure that that you're really aligned and you're in sync with what the driver knows about the cluster and what the cluster actually knows about the various types that are available. So in this case, this is the easiest way of doing it. And again, in the case of Node, this is actually quite a lot easier, right? Where you basically just set up a small JavaScript object and you just pass it to the query. But in this case, for Python, you have to take that extra step that you define your class, right? And then you refer to it when you create your query. And that's all I wanted to say. And look into the code. We're going to look at it in a moment. It's really not that difficult. It's just one of those things where we have a difference. Yeah. And if you look into other drivers like Java, C#, etc., they all have their own ways of dealing with UDTs.
Yeah, excellent. Okay, moving on then, we get to jump right into that exercise, the code Bettina just talked about. So we're going to go ahead and go back to our Git pod here, and I'm going to open up the file for exercise 5. All right, there we go. So you'll notice we have this whole UDT set up. We're actually using a class called location to define it. So when we go through and we're actually inserting, you'll notice where is that? It's down here. I'm getting lost in code here. Location, insert location.
So in line, I think, hang on, in line 21, I think you're actually referring to it in the prepared statement, right? And then when you're binding it, so a little bit in the...
Here we go.
I think it's a bit further down here, yes. Then in the batch, it's in line 46 in this case. Yep. So there we go. That's where we're referring.
And each of these XYZ would be a variable, which you see we're actually kind of pseudo-randomizing the random int here. This is a little generator. Obviously, if it was actually a sensor, we'd be getting those values back. But since we don't actually have a spaceship in orbit, we should get a spaceship. We should launch a spaceship. That'd be awesome.
We should get a spaceship.
but we're having to spoof that here, so that's where that's coming from.
a couple more things about the code here. Obviously we are generating quite a few data points here, so you can totally modify that. I set it to 1,000, so because we can later use that when we page through the results. This is one of the last exercises. But we're basically generating some readings here to make it a bit more interesting. And then we have this little sleep in there, sort of like, to stagger them every 10 milliseconds. Yeah. And we are going to insert 1,000 records basically for each dimension. This is all the same for location and for pressure, speed, temperature into the database. So we're going to write 4,000 records for a journey, and then makes it. You can, if you don't want to wait, it's going to take 10 seconds to update. If you don't want to wait, you can obviously set the total to much less.
Yeah, but 10 seconds
like 100 or 50
is nothing.
Yeah.
Okay.
I might not have adjusted the timer on the node side, so I think it might take a little bit longer on the node side, but not that much. I don't know. Can't remember.
Well, we'll see, because I'm running it right now. And there, yeah, it's going to take longer than 10 seconds, but it's running. So it's basically inserting a whole bunch of records, and we'll, as soon as this is done, actually, before this is done, we can go and we can go back to our CQL, and, which table were we inserting into? We were inserting into 4 of them.
All 4, all dimensions.
I'm going to grab one of those here, and I'm going to select star from, oops, did that.
You need to select the key space again. Yeah, exactly.
Oh, yep.
Yeah, I need to get into it.
Good point. Actually, I'm going to type in the...
That's cool.
Yeah.
Yeah, exactly. You can use autocomplete with CQL shell
you'll
there.
notice this is when I said earlier we can explicitly define the key space we're using in our commands. This is one place where I'm actually doing that. And that's just as an example here. So, wow, we've got data. We've got a lot of data. And that's awesome.
Exactly.
So basically, we're just writing in all these rows. The data is in fact there. I think I just proved that. And yeah, there we go. Okay, and it's still writing, or yep, still going. So at the time I ran the command, there was like 831 rows in there. We're completing.
Oh, it's taking longer than 10 seconds.
It definitely did, yeah. Okay, there we go. Reading, save, journey. There we go. Success. Boom! We did it. We actually went and traveled. Now, the one other thing I'm going to do here is I am going to go ahead and do a select from, oops, space, autocomplete slow all of a sudden.
Don't forget to say what you want to select.
Yeah, I'm just gonna use spacecraft, and I'm going to do select star from. We want journey, which is spacecraft underscore journey catalog. All right, so everything is there. Notice we haven't ended our journey yet. We've just been traveling. So again, this value is null. I just want to point that out for the next step. Okay, so we're going to go ahead and scroll through that. We talked about all of that. All right, so we're going to have to now, since the journey is over, we've got to mark it as complete, which is going to be, as you might have guessed, is it going to be an update statement? Is it? It is!
It is.
The reason I make kind of a joke out of that is, in Cassandra, there's a behavior called upserts, where if I were to run an insert statement with all that same, all those same values, and change the one that I wanted to update, it would actually do what's called an upsert, which is entirely an okay behavior. It's actually an insert that updates. And you can also use an update statement that actually inserts. And technically, a delete statement also inserts a marker on data. Every operation you do in Cassandra is, technically speaking, deep under the hood, it's an insert statement. So insert statements are very, very powerful tools. We're not gonna play with it too much, but I do just want to point it out. If you're running a bunch of inserts and updates and you start seeing like, wait, that data changed. How did that data change? I would check and see if you did an upsert. That is a behavior that does occur. Okay, so what are we doing here? we're taking an update statement. We are doing just a simple statement. We are selecting, again, the same UUID that we had from before, our Cooking Show Magic UUID. We're selecting that particular journey. We're going through, and we are doing an update, and we are basically setting it to, where is it here? Spacecraft name, date, time, now. There we go. We're setting our end time to false, or sorry, our active to false, our end time to the date time now. So it's like a timestamp that just says whatever now is, that's our end time. And then we're defining spacecraft name and journey ID to actually reference which particular journey that is. Okay, so I'm going to go ahead. Like always, I'm going to run that. 06 this time. And it's going to start, success. And if we go back to our database, I'm going to run that exact same command I just ran. Select star from journey catalog. Oh, look, our active changed to false. And we now have an ending timestamp. So that journey is now complete. Pretty cool. Simple update. Yeah, we've landed successfully. Or maybe we crashed. I don't know. Maybe it ended due to a
where did we land? That's my question. So where?
Yeah. All right. Next step here.
Okay, so there were a couple of questions in the meantime. Absolutely. I think it's like, so one of the questions was, what does CAAS stand for, right? When you log into Astra, right, and it says you're now connected to the CAAS cluster, and that's just Cassandra as a service.
Yes.
It's just the name of this kind of deployment, probably the name of this internal cluster that we are sort of like in there.
Right.
So don't worry too much, it's not that important. But it means Cassandra as a service. And so that was one of the...
I will point out there, if you're running your own Cassandra cluster and you're doing everything on your own Cassandra cluster, this is actually something you would have defined when you set up that cluster. So there's actually a field in there in your Cassandra YAML where you actually have to type out what do you want your cluster to be called, and you'd go ahead and type that. Since we're managing that all for you and it's all self-service, like Bettina said, that's just the name that we use, but if it's your own cluster, it could be, basically anything you choose. Yeah.
And then there's another person who pointed out that we have actually again forgotten to upload the slides, and this is so my fault. I keep making this mistake week after week. So we will upload the slides immediately after the workshop. I keep making changes right until the presentation, and I keep forgetting uploading them. So there will be in the GitHub repo. My apologies. Yeah. Once we're done with the workshop.
Any other questions here before we move on?
I think there were a couple of connection problems for people, but mainly because of misspelled passwords, I think, which is obviously easy to happen, right?
Yep.
I think Abhijit has a question about line 45 can be written in line 32. Why do we need to get a new batch statement always? I don't think that is correct. I think, are you referring to the
line 45.
To the which code? It's exercise 5, right? And the Python code. Let me just have a quick look at that.
Yeah, he's saying use the batch statement outside of the for loop as opposed to creating a new batch statement every time.
That's totally true. No, actually not.
Yeah, you could,
because we want to send a new batch for every reading, exactly. Right? For every time.
Exactly. So it's a new instance of the batch. Because if you think about it, if we had one instance for the batch and we just kept using that batch.add, we'd just be growing this batch and resubmitting a ton of queries over and over and over again. So we don't want to do that. We just want to submit this once and have it use a new instance.
That's a good point, actually, because batching Cassandra statements is not batch loading, right? Batch loading this is not to be confused, right? So it's so bulk loading. If you want to load a lot of data, say if you want to load all of the data for a journey in one go, you would want to you don't do it with a batch, right? Yeah. You want to do it with a bulk loader or something like that.
Yeah, it would actually be
so it's really not. This is not for bulk loading. The batching.
It would cause you some problems if you did it that way. And yeah. Again, I said this earlier, I'll say it again. any other system you have used batches on, it's a different concept. They're not the same kind of batches as what you've used on pretty much any other system. In fact, I'm not aware of any system that uses batches the way Cassandra uses them. Batch, honestly, the batch keyword is kind of unfortunate because there is such a context around it in the database world and what it
Exactly.
historically has meant. Cassandra, it has no relation whatsoever to the traditional batch. So please don't try to use it like one. It will cause some pretty big issues for you over time. Okay.
And then we had just on YouTube is a few questions about how do you create a new key space in Astra.
Yeah.
So you cannot create it through the CQL console.
Right.
So you might want to just
Yeah,
show
I can show that real
for
quick.
a moment. So if you try to create it through the CQL console, you actually don't have any creation permissions this way, right? And you will get a permission error.
So
But you can create it through the UI.
right, and that's this
right?
little add key space button right down here. If you're on the summary page in your database, just scroll down, you'll see the key spaces. You'll see my spacecraft is there, and if I wanted to add a key space, I could go ahead, type a new name in there, hit save, it would create a new key space, and then it would be usable for my code. But I'm not going to do that here today. It's totally something you can do if you felt like it. Okay.
Exactly. So normally you can do it, if you have your own Cassandra installation and the permissions are correct, you can do it through the CQL console, but not with Astra.
Yeah,
okay.
Absolutely.
So.
Anything else?
Good. Let me just quickly check whether anything else. There was a question earlier, I'm not sure whether that's still relevant, why the table spacecraft journey catalog doesn't have a partition specified. It does. You wouldn't be able to create a table otherwise.
Yeah.
So if you're still on the console, Erick, perhaps you can quickly show the table.
I need this. CQL console. I think I'm here. Okay.
The table spacecraft journey catalog. Every table in Cassandra has to have a partition key, right? It's absolutely essential. So it would be in there.
Right.
And
I think I know what the question is. So the way this shows up, and this is kind of a tricky little gotcha, if you just have single parentheses and you have a value, comma, value, it will always default to taking the first thing, the first element as the partition key. So it does have a partition key, and then the second one would always be a clustering column. If you want to be explicit about this, say you wanted to use a composite partition key, or you just really like being explicit in your code, which I am a fan of, the more you can define, the fewer mistakes you're going to have. Then you would do parenthesis, and then your partition key, and then close parenthesis, and then list out your clustering columns, then another close parenthesis at the end of that. So that's kind of, it's a tricky little thing. Good eye there, catching that. But yes, this actually does have a partition key, and it's just an implicit way of representing that in CQL. Yeah. Good call, though. That was an excellent catch.
Cool. And then one last thing I think about how to make the injection safe, right? So, for example, by using prepared statements, right? Because then it's first prepared and you cannot just leak it in there. Perhaps you want some additional answers to that?
No, prepared statements is the right answer. I mean, obviously sanitize everything that comes from user input, no matter what it is, no matter what system you're running. That's just best practice. Sanitize your inputs. But yeah, prepared statements basically are disallowing you to inject code snippets into your things. It takes a value and it takes a prepared statement, and all it's going to do is apply that value to that statement. So there's no opportunity to inject, like a sneaky select statement or something in there. 1 equals 1 log me in, ha 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 ha. Like all of those things, injection attack wise, don't work when we're doing it that way, because everything's defined for you. There's no way to break out. There's no way to kind of trick it. Yeah. Okay.
And then one last question, I think this is an interesting question from YouTube, is whether you can actually link your Astra instance to your GCP account and see it from your GCP console. Not when you set it up like this, but you can actually launch Astra directly from the GCP marketplace, as far as I know,
I
right?
believe, yeah, I believe that's still a thing. If you want features like that, please provide feedback to us. We can take that back to the team, and if that's something you'd find useful, the more voices that speak up on things that are useful, the more we can help to influence. As advocates, we also get to advocate back to product for our user base. So the more info you arm us with, and the more voices we have asking for things, the more we can go back to a product team and actually advocate for a change. So if that's something that matters, please let us know. Okay.
Cool. Move on
Yes.
and do some more coding.
Straight
How
into
about
the
that?
last set of exercises. There are 4 of them here. We're going to blow through them kind of quick. If I'm going too fast, please call me out. I can slow down. I can talk about something. If there's any questions, let me know.
Yeah.
All right.
There isn't actually a lot of slides for those. It was more meant to look into the
Absolutely.
code, but if anybody wants more info, we can provide some additional stuff here.
Yeah. So, okay. So what we're doing here is list journeys. That's literally all we're doing. It's essentially that same statement I've been running this whole time to show you guys what's in the journeys table. And you'll even notice here, select star from spacecraft journey catalog. Good grief. Where spacecraft name is. So the only difference is that we've actually now bound it with a where clause, and we are actually taking that name that we've been using throughout this whole process, and we are using that. That's the partition key. We're basically just referencing that and saying, give me all the journeys that this spacecraft has gone on. So if we had multiple journeys, for example, with a whole bunch of different identifiers, that UUID was different, it would actually give us a list of journeys. But in this particular case, since we've only gone on one journey throughout this process, it is going to return that one particular record. And I'm going to go ahead and I'm going to run that. X07, and we will see here down in my console, we have our journey, we have the ID there, we have a summary, bring astronauts to the International Space Station, and we can actually go all the way over here, and we can see that those values are in fact the values that are stored in my table. So again, we're not doing any trickery here. That's actually what's stored in my database. That's actually what I'm returning. Pretty simple. All right.
And actually, this is pretty boring because we only have one journey. So if you enter a lot more journeys, then more interesting a table, right?
Yeah.
So at the moment, I thought, why am I seeing only such little data? It's only because we only have one journey in there. And so we encourage you to get testing with this and try some funky stuff, and see whether you can actually build it up a little bit.
Absolutely. Okay, so now, we should actually, maybe for the next run of this, we should make it where we're doing like 5 or 6 journeys within one, because we're now going to do essentially the same sort of thing here, but we're going to also reference it by clustering column. So we're going to read a specific journey. So again, if I had, for example, I were displaying this all on a nice dashboard, right? And I want to click on that journey, and I want to see what the info is on that journey. I would submit the spacecraft name and the journey ID in my query, and voila, I would get data back. So this is actually going to look the exact same data is going to return Python EX08 read journey, and I'm going to get that exact same data back about 2 seconds with kind of it broken up into a nice format. And you can see we just literally formatted Python print statements with the formatting there, but we just broke that data up. Same data back.
But I think there's a couple of things to say here, right? I mean, first of all, you have this kind of the return, what you get, you can actually pass through it by selecting the different column names in the row.
Yes, that's
right?
An excellent point.
So that's... Yeah, go ahead.
Excellent point. It's a result set is what you're getting back. It's a standard result set object. So, yeah, absolutely. You can take... you'll notice we got the for statement in there, so if we had multiple journeys, it would list them out in chunks. and then we're just referencing a row and then the column name. And since it's a result set, it's basically all of the column names are referenceable. And you can pull data out based on those. It's a really easy way to work with data. It's actually very similar in feel and function to like a data frame, if you've ever worked with those. Python data science people, if there's any of you out there, I'm sure you've used pandas with Python and messed with data frames. Very, very similar concept, very, very similar feel. Should feel right at home. All right. So yeah, we're breaking all of those out, and we're printing them in a nice format. But essentially, it's the same data we returned from our last query, where we just returned a raw little block there. We're just, again, referencing it by the clustering column. So specific journey ID, the last it would have returned every journey the spacecraft had been on. Okay. Next, I'm going to go for number 9 here. All right, so what are we doing with number 9? We are going to do a select star from spacecraft speed over time. So we're actually going to one of the sensor tables, and we're selecting it by spacecraft name and journey ID. So we're getting all of the data back from a specific journey of a specific spacecraft. And again...
And do you think that's a clever move? Do you think that's a clever move when you have 1,000 records?
Well...
It's probably still okay for 1,000.
Yeah, it'll be fine. Yeah. I totally know what you're saying, though. We're doing the exact same thing here where we're parsing out rows. Now, this is an interesting one from the last one because we're actually getting multiple rows back. So we're actually going to parse out a bunch of different rows, whereas the other one, we just returned one row and parsed it out into this nice little block. But essentially, we're doing the same thing. We're parsing out this row with, all these different values, and you can see we've got a print statement again. We're just printing out row.speed, row.reading time, nothing too complicated here, but it's going to give us back a whole bunch of values. So let me go ahead and EX09. And that will start printing out here. Whoa, that was quick. See, it's quick on reading. And the reason for that is that we're denormalized. We didn't have to do any joins. We just went out, said, that's the data we want, return the data we want, boom, done. Simple as that.
And it's giving you the whole partition,
yep.
Right? So this is all in one partition.
Yep,
so it just has to go once to the disk and read it out basically and give you the partition.
Yeah, we can see the values there.
This is how Cassandra stores the data, right? It stores it all together in one big chunk, and for that partition.
It's really interesting too. If for anyone who's interested in like drive IOPS and how this stuff actually functions, you can return this sort of a partition with a single IOP. It's one of the super powerful things about Cassandra, that like a relational database, the minimum you could do on the best day with a brand new database, and it's the second Tuesday after the winter solstice, is going to be like 16 IOPS, and even then that's like a theoretical perfect scenario. Cassandra just takes one, so really cool. Yeah, really cool. All right. Next, let's move on to the very last exercise here. Now, in this particular instance, I believe we got our simple statement with our query, which we've defined above. Now, you'll notice the same way we were defining our prepared statements, we basically defined a simple statement where we actually are setting it to a variable, just like you could in any language. We're setting it to a variable with our little string replace there. Again, if we're using string, not integer, not anything else, use string there, or it won't work. And then we're running our query, and we're running fetch size. Ooh, what's fetch size? Well, in the driver, there's a thing called paging. And paging is how you get back a chunk of data, a subset of the whole data you want returned. And what that's going to return to us is the data and then a pointer to the next set of data. So what you got here, if I can show it here, we got our statement we're submitting, we've got our key that we're looking up off of. We're going to go ahead and we're going to print current rows, and then for offset, we are going to, offset, I put current rows, where is it here? Am I just missing it there, Bettina? Can you see it?
So we see,
there it is. Page state. There it is. That's what I'm looking for.
Exactly.
Yeah, and that's basically that pointer that I talked about that says basically jump to the next place, give me the next set of, I think in this case we had fetch size set to 10 records. Default, I believe, is set to 2,000 from the driver. So in this particular case, we only have 1,000 records. It'd be hard to show paging with 1,000 records if our page size
I
is
think it's
2,000.
even more. I think it's
Is it
5,000.
5,000?
But
Okay.
I think that's why we had, that's why I thought it made sense. You saw how overwhelming it is when you get 1,000
Right.
statements at once, the 1,000 results, and now we're just gonna page them out, right? And then we store the pointer to that with the paging state. There was a question from somebody on Slido what the paging state is. It's exactly that reminder, until what point have we paged, and then we call the next page, for starting from that paging state.
Yeah, absolutely. So we're going to go ahead and we're going to run that here. So we're going to Python. I'm going to do ex0, whoops, 1. We're incrementing past 9. I'm going to run that here, start exercise, and that is going to, ooh, that was so fast you could barely see it. That returns 10 values. Now, I don't remember if I set this one and I run it again, if it's going to actually run through and...
It should actually return 20. It gives you 2 pages. We only set it for 2 pages in the
there
code.
it is, yep.
Right, so first it gives
Page 1.
10 pages, and
Page
then
2.
gives you the paging state, and then it resets the offset, which is just the IDX count.
Right, and I will point out here that we actually show you what that paging state pointer looks like there. That's just printing out the raw, the paging state object. It's never something you would actually do in a real application, but it's something to kind of illustrate that yes, this is a real thing. This is something you can store and something you can pass with the statement. So that's what it looks like. If anyone here was curious. All right. With that,
and as you see in line 26, we pass the paging state to the execute statement, right? To the driver here. So we pass. So it's an additional option that we're passing. We're passing the query, and we're passing the parameters, and we're passing the state, right? So in order to build the second page.
And remember earlier when I said we get returned to the result set and the page state, that is part of the output. So we're just, the way we reference that is just output.pagestate. That was, where we're referencing rows, we're saying, where's there? Output.current rows. So it's just another piece of that object, essentially. If you're thinking about it like the very Python way of thinking about everything in classes, it's just another piece of that class. So, all right, moving on. So that was our last exercise. Oh, yeah, what's up?
Yeah, I just want to know how everybody's been keeping up and whether that worked out. And I think we don't print the paging state out with Node. I don't think we did that, so we can probably add that.
I'll admit I didn't try out the Node code. I am a Python enthusiast. But yeah, okay. So yeah, most of these from this point on are just going to be covering what now. So what we have here is a call for you guys to interact with us. We want to see what you guys are doing with Cassandra. We want to promote you guys. We want to make you guys awesome. If you guys are making something, if you have a cool app, and you've built it, and it's something you want to share with people out there, contact us. Let us know. Let us take a look at it. We are more than willing to help you guys succeed and help you guys make a name for yourself in the community there. It's our pleasure to do so. So please reach out. Okay, if you have any feedback on anything Cassandra, Astra, or just general, our community related, please provide that to us as well. We really, really do live off of feedback from our community. So, please be active. Please be interacting with us. Please be providing that. There is also here, community.datastacks.com is another great way to get in touch with us. We didn't really touch on that one earlier. It's kind of our blog, Stack Overflow thing that we host, that we interact on. Most of the advocates are out there answering questions. So definitely go check it out. Interact with us there. There are also vouchers. Let's see, I think I have a slide. Nope, I don't have a slide for that. There are also...
Oh, I forgot to put a slide in there. Yeah. We will give out certification vouchers today. And I think our colleagues probably put the
if we can
slide,
get
the form into the chat.
Go ahead and click on that form, fill it out. There is a little bit of info that we ask, and then you can basically get a certification voucher, which will allow you to have an attempt to take the Cassandra certification test. It's basically a free attempt at the certification test. So
yeah, I want to say something about this, because we ask in the voucher that you give us a GitHub repo with your own efforts.
Yes.
We want to see how you use Astra, right? So, and we give you an example repo in there if you find it hard to get going. But I've seen some submissions from last week, and they look pretty good, right? So really interesting things that people have started to make their own app. So if you want to be bold, show us your own connection code, show us your, just do something in the repo, how you connect to Astra and what you're doing with it.
But do something that's yours.
Tell
Don't
us
just copy our work. All right. Wonderful. Well, with that, I am going to say thank you all for joining. The fact that you are here and watching us means we get to keep doing it. So you're keeping us employed. I appreciate that. You're also keeping us doing stuff we love to do and letting us talk about stuff that I think we're all on this team pretty passionate about. So really do, from the bottom of my heart, thank you guys for coming. Please come to more of these. You know, we have all sorts of topics. I think Monday Learnings right now, we're covering Docker, how to use Docker. We've got some meetup sessions. So the Cassandra meetups, obviously due to COVID, we're all kind of shut down because we couldn't meet in person. We're trying to bring some of that back in a virtual way. Getting some, speakers from other places, just talking about cool things they're doing. So come check us out, hang out with us, come to the Discord. We love to interact with you guys. All right.
Yeah, so next week is a spring, so we're going to do spring reactive, and we actually, I think it's co-hosted with somebody from Gitpod.
Yeah.
So if you have any questions there, so that's really recommended.
Yeah.
And see you again.
All right.
Thank you so much. That was good fun.
Have a great day, everyone.
And as always, don't forget to click that subscribe button and ring that bell to get notifications for all of our future upcoming workshops.